Hello, good morning, good afternoon, good evening, wherever you might be. My name is Sean, and I'm delighted you're joining us for today's ESPC community webinar. This webinar is part of the Microsoft Fabric Week, proudly sponsored by Actares. Today I'm joined by Sandeep Pawar, MVP, who will present Unstructured Data Transformation in Fabric using AI functions. We love hearing you guys have to say, so remember to join in conversation about today's webinar. Our handle is at ESPC_community and our hashtag is hashtag ESPC25. Tweet us, tag us, and tell us what you learned. Don't forget to check out our Learning Hub, which is updated with the latest blogs, ebooks, webinars, and how-to videos. You can access and view the Learning Hub by visiting our website, sharepointeurope.com, and clicking Content tab at the top. Don't let the learning stop here. Continue to keep up and stay ahead by joining us for our next webinar, Exploring the Art of Conditional Formatting in Power BI with Anastasia Solari. This webinar will take place Friday, May 30th at 11 a.m. CEST. For more information on this webinar, please check out www.sharepointeurope.com/register for webinars. Looking to level up your Microsoft Fabric skills? You don't want to miss FabCon Europe, the European Microsoft Fabric Community Conference happening 15th to 18th September in Vienna. You will experience 3 incredible keynotes, 10 full-day tutorials, and 130 plus sessions led by Microsoft experts, MVPs, and community leaders, all focused on data engineering, real-time analytics, Power BI, governance, and more. There's also hands-on workshops, great for networking, and awesome event socials. And here's the best part, you can save €150 today. Just use the code FABRICWEEK150 when booking your ticket. Scan the QR code or head over to www.sharepointeurope.com/European Microsoft Fabric Community Conference and grab your spot. Want to go deep on Microsoft Fabric tools with hands-on learning? We've just launched a FabCon Europe tutorials packed with practical sessions on Power BI, Microsoft Purview, SQL, data warehousing, Fabric, data agents, and more. Learn directly from Microsoft and community experts and walk away with real-world skills that you can apply immediately. And don't forget that you can save €150 right now and use code FABRICWEEK150, but it's a limited time offer. As always, if you have any questions at any stage, feel free to type in the questions box and Sandeep will get to them during the webinar. This webinar will be recorded and added to the Resource Center where you'll be notified by email when it's available. And now I'm going to pass you over to today's webinar presenter, Sandeep. Hello, Sandeep. Thanks for joining us today.
Hello, Sean. Thank you. Let me go ahead and share my screen. And let's confirm you can see my screen. All good.
See the screen, yeah.
Okay, perfect. Thanks again, Sean. And well, good afternoon to everyone and good morning. And if you are from my part of the world, super early good morning to you because it's 6 a.m. my time. So thank you for joining me. My name is Sandeep Pawar. I'm a senior architect at Hitachi Solutions in the US. I live in Portland. Sean mentioned, I'm also a data platform MVP. Been part of the Power BI and the Fabric community for almost 10 years now. I enjoy being in the community. I enjoy learning from the community, and I enjoy sharing with the community whatever I learn. So I have 2 blogs. The one that is active right now is fabric.guru, where, as the name suggests, I write things about Fabric. So at Hitachi Solutions, we are a Microsoft Gold partner. So we work with a lot of companies, several companies, to implement not just Fabric, but other Microsoft data products such as Azure Databricks, Synapse, but currently very much focused on growing Fabric and implementing Fabric for our customers. I'm also active on the social media, especially on LinkedIn, where I post almost on a daily basis, tips, tricks, and things that I find interesting in Fabric and things that I have learned from based on my experience. I post sometimes on Twitter, but not very active these days over there. But feel free to follow me if you are curious about Fabric and just in general learning about Fabric. The agenda for today we'll talk about the AI in Fabric in general. Then what are AI functions? will go into the evaluation and the operationalization of AI functions, and then I'll show you how to calculate the cost as you are implementing these and using these AI functions within Fabric. So in Fabric, there are several Gen AI features available, right? And so if we start from the very top, Copilot, and that's probably the one that everybody is very familiar with. That's the Copilot, same Copilot experience that you have not just in Fabric, but the entire Microsoft ecosystem. And the idea for the Copilot is mostly for the business users to use a chat-like experience on top of your data, on top of your documents you have, or any other data source that you have within Microsoft. But specifically within Fabric, you have a Power BI Copilot where you can ask questions, natural language questions about the data, and the data can be data which is in Power BI or anywhere else. There are also developer Copilot experiences like the Copilot experience in, let's say, data warehouse, or Copilot experience within notebooks, which are more developer focused, where you ask a question and then you get a response back, which is more like, hey, how do I write code, or how do I write this DAX function? How do I optimize this DAX function, and such things. Data agents, on the other hand, it's more of agentic AI experience where you add data sources. Currently, there are, I believe, 5 different data types, data sources that are supported within Fabric. So you can add a semantic model, a KQL database. You can add lakehouse, warehouse. To the data agent, you can give it instructions. You can evaluate it and then publish it for your business users to use it. Then moving towards more pro code developer experience, you have Azure OpenAI services, which is within Azure has OpenAI services, right? The AI Foundry in general. Within that, there are Azure OpenAI services, which is specifically using OpenAI models like ChatGPT 4 or 3.5 or 4.0, 4.0 mini, etc. And you can use that for as a more Gen AI experience, that is generative AI experience for a lot of the different tasks. The beauty of this is if you do not have an AI Foundry resource in your Azure, then you can Fabric by default, it provides that. You don't need anything, even if at an F2 capacity, you can use certain endpoints within Fabric without having to provision OpenAI services in AI Foundry, which is awesome. And I've written several blog posts about that, which I'll point to as we get towards the end of this presentation. And this brings us to the topic today that we have, which is AI functions. AI functions, will get into what AI functions actually does, but at a high level, what AI functions is, before AI function was launched, the Azure OpenAI services that I talked about, the way you use that is you either via calling an API endpoint or using Synapse ML, you could use it for a variety of purposes. But in the blog post that I have written on this topic, where I talk about unstructured to structured, you can use it for converting unstructured data into structured data. So one example that I wrote about was, let's say you have Microsoft blog posts, right? And then you want to extract certain entities out of that. Like, let's say a feature is released, and then you want to extract whether that feature is new and which workload it is associated with. Even for the Fabric conference, the European Fabric conference, I wrote a blog post on how you can scan all the event presentations and the sessions and extract data out of it, that who would it be good for and what are the topics. Is it more for newcomers or is it more for advanced users, and such things. But if you want to do that, you have to write the prompts. You have to tune the prompts. It's a more pro code experience. If you're somebody who is coming from or migrating from existing Azure OpenAI to Fabric, then that gives you a nice way of that migration path. But what Microsoft has done is, Fabric being a SaaS platform, they want to, let's say, democratize AI, right? So for the developers who need the flexibility, the power of AI, but the flexibility and ease of using it, they launch these AI functions, which it's more than a wrapper, but in some abstract terms, then think about it as wrappers around these OpenAI endpoints or the SDK, where you can do certain things very easily without having to go through a lot of exercise of writing this. Similarity, and we'll talk about all of this, but these are the main AI functions that are available currently. The list will likely grow in the future, but similarity is a similarity between different text classification. Extraction is entity extraction or topic extraction. Translation is translating from one language to another language. Text generation is the more chat kind of an experience, or you generate responses or generate text from the given prompt. Summarization is if you have long text and you want to summarize it, you can do the summarization. And then sentiment analysis. And these are the only slides I have. I don't like slides very much. So we'll get into the more hands-on part of this, where I'll walk you through a couple of examples on how you can use AI functions, what are some of the things that you need to keep in mind as you are developing, and then most importantly, how you can operationalize AI functions within your organization. So let's head over to and I'm just going to zoom in a bit here. Okay. So first things first, to use AI functions, you need a Fabric, or you need a notebook in a workspace that is backed by a Fabric capacity. The capacity, as long as it is a paid capacity, it doesn't matter what SKU you're using, even if 2 SKU, thanks to the recent announcement that all AI and Copilot experiences in Fabric are now available even at the lowest SKU. So that's a nice thing. You do have to enable enable it in your tenant settings. So if you run and if you see that it's not available, likely the cause is that it hasn't been enabled. So you definitely need that. So talk to your admin about enabling it. Look at the documentation for exactly which setting needs to be enabled. There are a couple of them, but do that. And you also need the Fabric runtime 1.3. So currently this is only available in Fabric Spark notebook. So which is, if I go here, you'll see PySpark. So this has to be PySpark. And if I go to the environment, you see this is a runtime 1.3. So that is a requirement. You can't run it on anything that's earlier than 1.3. Then to get started, you will need to install AI functions. And this is a temporary experience where while it is being preview, you have to install it manually. But as it matures, hopefully in the near future, it will become part of the runtime, the 1.3 runtime, and you won't have to install anything. You just import it just like any other library, and then you'll get it. In this case, and you can look at the documentation, it shows the code there, what exactly needs to be installed. I've already run this and I've already imported the data here, or the libraries rather. Let's go ahead and import the libraries, and I'll walk you through what exactly we are going to do. So in this case, I have and I'll show you exactly what I have. I have a data set where I have saved it to my lakehouse, which is here. And if I go to files within here, I have the data in this folder. And if I walk you through what's in that, you'll see that this is some data, about 1,500 lines of data, where I have country in the first column, a restaurant name, a review title, review date, and the review. So basically, this is nothing but, let's say, Yelp. I don't know what they use in Europe, hopefully Yelp, but Yelp basically for gathering customer reviews. Could be Yelp or could be maybe hotel chain, and they want to gather the reviews, right? So this is a nice table of, okay, what the title is, when the review was submitted, what exactly the review was, and which restaurant it was for. If this is very common, so when I work as a consultant, typically, in most cases, something like this resides in a Power BI model where the customer they just go and then look at and read the reviews, right? So recently, I had one customer where a chain of hospitals, and they had reviews from their doctors, reviews from not reviews, but case notes from their doctors, case notes from nurses, etc., where it is all text data. And how do you get insights out of that data? In most cases, before AI, it was just something that you read and go through a bunch of these reviews and text, and then maybe create a mental model out of that and maybe jot down some insights. But thanks to AI, we can really work on this type of data, the text data, and gather more insights. And what I'm going to do in the first demo that I have here is we'll walk through what are the different AI functions and how you can use them, and then think about the different use cases on that. Now, the very first and the most obvious one is sentiment, right? Now I have the review, and I want to understand what is the sentiment of this review, right? Positive, negative, and I can do that very easily using AI functions. Now notice that here I didn't have to do a whole lot. I just imported synapse.ml.ai func and import conf. And the way AI function works is, instead of have typically in Gen AI, you write the prompt, right? In this case, Fabric has already taken care of all of those things for you. And the way you work with this is you can, let me, the way you work on this is you always work on a column. So in this case, let's say if I go to restaurant review and then .ai, and then whatever AI function that I want to use. Here you'll see that I have these other AI functions that are available: analyze sentiment, grammar, generate response, similarity, etc. As the name suggests, analyze sentiment, that's exactly we want to do, right? So I'll go ahead and then run the analyze sentiment on this column, and then store the sentiment that I've extracted you to a column called sentiment. Now this can take a while depending on the amount of data that you have. You have two flavors while this is running. There are two flavors of AI functions that are available. One, that is AI functions that you can use on a pandas data frame, which is what I'm using right now because I don't have a lot of data. This is just 1,500 lines of data, so nothing crazy. Or you can also use PySpark. So if you have a lot of data, millions and millions of rows, and you need to use AI functions on top of that, then you can use Synapse ML, and you can use the Spark version, the PySpark version of that. Here, I'll just go through the Pandas example but you can look at the documentation for how the PySpark version works. You can see here that this is already taking very long, a minute, and probably go on very long. So let me cancel this, okay? And the reason I want to cancel this is because by default, when you use the analyze sentiment or any of the AI functions, it will use the defaults. Um, but there are certain defaults that you can use within, or you can change those defaults by defining a configuration. So let me copy this part here and let's go here and then say my configuration is the temperature. Let's get rid of temperature for now. And let's say max concurrency is equal to 100. And let's go ahead and run this. And hopefully this will run faster. So what did we just define? In this case, what I'm defining is the concurrency of how the data should be processed. So notice that earlier it took a minute, maybe a minute and a half, and it was still going. In this case, I defined max concurrency as 100, that it is applying the AI function on batches of 100 rows at a time. So that speeds up things significantly. So when you are working with data, and I would say irrespective of the amount of data you have, you should define the max concurrency here so you can speed things up a bit more. So look at, let's see, look at what we get. So we have the review and then we have the sentiment associated with that review. So let's just eyeball a few things here. If I click on the first one, says the manager became aggressive. Yeah, that's definitely negative. If I scroll down a bit more, this one was highlighted as input filter violence. Um, because perhaps there is some foul language used or some trigger words that were used. And this is another thing that that separates AI function from if you created something like this on your own. When Microsoft creates something and then puts something in production like this, they have to go through stringent RAI process, which is responsible AI process, where they make sure that when the user uses it, it adheres to or complies with the responsible AI practices that Microsoft follows in all of its products, which is no bad language, it is not racist, it is not using any violence, such etc. Let's look at something that is perhaps positive. Yeah, wonderful experience and everything. Now, in most cases, when you are creating a sentiment analysis like this is where it stops, right? But that's not the whole goal. Why analyze the sentiment if you cannot act on it? So if I'm the restaurant owner, and let's assume that this is restaurants, and then they own these restaurants in various countries, and they have gathered this review, and they want to maybe get insights out of this. So they can identify potential issues, they can identify maybe perhaps the things that are going well for in these restaurants. So what can we do about that? So let's transform the data a bit more, where I'm just doing a simple group by based on the sentiment, and then by or the restaurant name and the sentiment and then the count, right? So if we look at here, we have, let's say, this restaurant here, Stara Kamenika, where it has negative 15 negative reviews, and then 117 positive reviews. The Frog at the Bursi Village, has 151, so about 50% of its reviews are negative and 343 positive reviews. So this one definitely stands out, that maybe there's something going on in this restaurant. Has this been going on for a long time? Is this a recent issue? What are the customers really saying, and are there any aspects within this review that are positive versus negative? Maybe their food is good, but the service is bad, or perhaps something else. that can, and those are the types of insights that we can get if we are able to use AI function in such a manner. So let's try to understand that a bit more, where what I'm going to do is I will plot this data. And to plot this data, because the sentiment itself, there are four types of sentiments here, right? Mixed, negative, neutral, and positive. The neutral is very rare. So what I did was I created a mapping where if it is a positive review, I assign it number one. If it is mixed, 0, and if it is negative, then it is -1, right? And the idea here is that we can quantify the reviews, the sentiment a bit more, and see what is the sort of trend we can get out of this. So when I run this, I can see is another thing that I did here is that because I have the review date, I did a group by the start of the week. So all the reviews are aggregated at the week level, and then I'm calculating some average, a weighted average based on the mapping that I just did. And from here, we can see that as we go from, let's say, 2025, from here is we start off with negative, positive, negative. So it sort of looks like it's all over the place. But for the most case, it is in the positive territory, right? So it is in the positive territory, but when it is negative, it is negative significantly. Whereas when it is positive and hovers between, let's say, 50 to 50% to, or 0.5 to 1. Um, but then this trend over here where it dropped significantly and stayed there for some time, and when it went up, not as much, right? And maybe perhaps that this would be a good insight for the managers to look at, that what happened after this point onwards. I also see there is some sort of a trend here that maybe every the start of the month is where the negatives go down, and it could be a number of different things. Maybe they change the menu start of the month. Maybe they have staffing policies that are different start of the month, and those could be the things that they can potentially start looking at. Now we looked at the reviews, but what about getting more insight as to what is in those reviews? And instead of again just eyeballing it and going through it, if we have ton of data, that would be very hard to do, right? We can use the classify function here, where I'm just zooming in on this frog at the Bercy village, and what I want to do is classify the review into three categories, which is food, service, and other. That if that particular review talks about a food, then I want a food label on it. If it talks about service, then a service label on it. And if it is something else, other. And the other could be, you can further refine this. But to just get started, let's see if we can identify if there are topics or if there are things that stand out here a bit more. So let me run that. And again, like I said, the max concurrency here, I defined that. The other couple of parameters that I've defined here, first is the temperature, which is, let's say the randomness controls the randomness of the LLMs. So oftentimes the one complaint that you get when you're using something like this is you don't get the same responses if you run it again, right? And that's because the LLM inherently is stochastic, meaning it generates its responses based on probability, and it will vary all the time. That is, we cannot control that. However, we can limit that by defining the temperature. That is how the randomness associated with how the responses are generated. And seed is how to control that randomness, where it is picking the tokens and generating the tokens. Always a good practice to do that, so that if you run this notebook again, there is no guarantee that you'll get the same responses back, but there is a very high probability, very high likelihood that you will get the same responses back. So I created the classification column here based on the review column. And now we have three things, right? So we have the review, the sentiment, and what is the dominant theme for that particular review. So let's again take a look at this. If I select the first one, says the manager became aggressive. So this is clearly a service related issue. So yes, this is a service related issue. Go to the next one. I ordered beef fillet. So again, service food related issue. Let's see another one. Very long review, and this person probably could have talked about food as well as service, but AI in this case determined that this is largely about service. So this is a nice way of identifying what are the topics within that, right? So which is again helpful. What you could do after this is do some sort of a clustering analysis, and then maybe trend analysis similar to what we did. So if I were the manager, I would further add a line here to see what is my mean score for service, what is my mean score for food. And if our hypothesis that maybe the start of the month they have bad service because staffing, or bad or negative reviews because they change their menu start of the month or every 2 weeks, then the food average rating would be lower compared to service. So that can give you another insight as to how the customers are feeling, and if there are potential issues with that. We can go one step further. Let's say again that thing that I noticed here, that the manager became aggressive. And now I want to identify whether this is a so when we did the classification and we tried to identify if the review is service related or food related. Now within service itself, there can be many things, right? It could be service as in the staff maybe gave them the food, it didn't arrive on time, or they ordered something and they got something else, or maybe the manager was bad, or it could be in a number of things. And what ideally were, if you were to maybe go to that restaurant and ask people with the staff, okay, what are the common themes that you're hearing? And you could maybe ask, okay, have there been incidences where maybe the manager is rude? And so for things like that, maybe you won't get an objective response back, but the reviews here can help us, and or at least point us in certain direction. So how can we do that? So within AI functions, there is another function called similarity, where you can identify or calculate similarity between two sentences, or similarity between two columns. So what I mean by that is, let's say if I have a column, this column here, right, review. And if I say the easy way for me to do this would have been that if I do a simple word lookup, or find to say manager, let's in fact go ahead and do that. If I do manager, everything is filtered by the manager. But if I want to look at maybe service, it has to be mentioned in that review, and I'll get everything related to service. But that's the keyword search, right? Somebody could say that I felt terrible after going to this restaurant because staff did not attend to me. And that is a service related issue. And if you look up for manager or look up for a service that won't show up. So what we can do is we can do a similarity search to identify the reviews that match that are closest to something. And in this case, I want to identify the reviews where the review is similar to the staff was unhelpful and provided a bad service. Now again, I'm focusing on this one particular restaurant here. So let me go ahead and run that. And what we will get in return is, and again, notice here that I'm not doing anything fancy. This is just, again, the review, dot AI, dot similarity, and then what is the value that I want to compare it with. And what you'll get out of this is the similarity score, which is nothing but a um, uh, there are different types of similarities, but the easiest way to think about this is either correlation or how close, this is a cosine similarity, so how close the two sentences or two texts are to each other. The higher the number it is, the higher the similarity between the two texts. 0.85 versus 0.84, the number itself, the absolute number, it doesn't mean a whole lot. So you cannot use that 0.84, 0.85 is just marginally better than 0.84, but what you can say it is they are close to each other. So in this case, I got that, and out of the whatever 300 reviews or so for this one particular restaurant, I am focusing on only the reviews that are related to service and the manager, right? So here in this case, let's see, go here, and they're talking about how the staff did not help them in this case, and they arrived and so on and so forth. So the idea again here is that if you have text data, you can get insights out of that data in various different ways. And this was just scratching the surface as to what you can do with it. As I mentioned, there are other things as well. So translation, for example, this is a global restaurant because we saw it was in France and it was in other areas as well. So if people write the reviews in other languages, you can translate that into English for maybe for a manager who resides in US, and then do the similarity search or do the extraction on top of the translated data. Summarization would have been super helpful in this case as well. So what I could do, let's say if I am again the manager of this restaurant, and I want to understand what is the overall review, how the reviews have been this week, right? Then I can concatenate all the text from the review column we have, and then just use .ai .summarize, pass that column, and then I'll get a summary of the combined review. So that's a nice way to get, let's say, a report card of all your reviews, right? Which is pretty awesome. Now, before I move on to the next one, if there are any questions, Sean, let me know. Otherwise, I can go ahead with my second demo.
Yeah, there's just one question in. How do you ensure production readiness and consistency when deploying AI functions at scale?
Yeah, perfect. Thank you for that. So let's go to that. Um, So this is how you do it. So the first one that we looked at was, one example, but how do you productionize it, and specifically when you are using it for making actual business decisions. So I wrote this blog post, and I've written several blog posts on doing this, but the two recent ones that I wrote, the very last one was you extracting structured data from Excel files. Now, Excel files, mm, we don't typically think about Excel files as unstructured data, right? So example being, let's say I have this data. If you are a Power BI user or even a Python user, there are some odd things here, like the data is not in a perfect format, but you can definitely can extract the data out of this, structured data out of this. Nothing fancy, right? However, things get tricky when this is not very well structured. So the case here is I recently saw this a Power BI user forum post where the user asked about, hey, I have this purchase order data and I want to extract data out of this. And somebody replied back that, hey, this is not a problem. You can write this M code and it will extract the data without any issues. However, they note here that is it always like this, or does it change? And that's where the rub is. That's where the problem is, where if that data changes, then you're out of luck. So let's try to see if AI function can help us with that. So try to simulate this use case and create a synthetic data for this. So what you see here is up at the top, you have the purchase order header details. So which is the delivery type, the delivery date, and then some sort of an address, and then this is the material transaction. In the second sheet here, it's exactly the same data or similar data. However, the structure has completely changed. Now from this is gone to this, where instead of one below the other in two columns, now this is next to each other like this. And the purchase order number, the job ID, instead of being here, it is mentioned in a merge cell. And if you worked with Excel, you know that merged cells, it's bad to deal with because you don't know which column to put it in. Hard to parse it. In the next sheet here, I changed this even more, where I not only changed the header details here, but I inserted another column, reordered the columns so they are not in the same order. I changed the column names. So notice that here this is material instead of material code, material description. This is material, and then code description instead of quantity. This is QTY. Instead of UOM, it is unit of measure. And then this is even more than that, where I create multiple, add more text, and then change things even more. And our goal here is, can we use AI functions to create structured data out of this? So let's see how we can do
Sandeep,
that.
there's a
Yeah.
question in, if that's okay.
Yeah, sure. Go
Um,
ahead.
which use cases can you imagine for structured data from F&O?
Yeah, so so this one, another one that I talked about in my blog is, let's go back here, where I extract data from invoices, which is very relevant to F&O, where uh, let's say PDF data. So let's go here. So in this example, a similar case where I have a PDF and the data is highly unstructured because one, it is a PDF, and then two, in this case, it is just scattered all over the place in the document. And we can use AI functions to extract data from this and then create structured data out of this. So anywhere there is, let's say, unstructured data where it is, and I define unstructured as something that is not structured, and it doesn't matter which file type it is, if it is text or not, it is unstructured in my opinion. So for this use case here, I will import again the things that I need, and then I will import the data. And as you can imagine, our goal here is, from this Excel sheet, I want to extract things. I want to extract the job ID, I want to extract the customer ID, name, and all of this, right? So if we look at the functions that are available, which functions is the closest? Well, extraction, right? That's easy to guess. So let's see how we can use dot extract. So here in this case, I've imported the data. and then we need to pass that data to AI functions. Now remember, AI function, it needs the data to be in text. It needs the data to be in a format that it can understand, because that's how LLMs work. To do that, what I'm going to do is I take the data, but I convert it into a markdown. Markdown is nothing but, sorry, markdown is nothing but the text that we write in the notebook. So if I go here and then write something, this is markdown, right? So we convert this into a markdown, which is essentially text, and then I pass what are the things that I want to extract. And I just define, use natural language that I want to extract: type, material code, PO date, etc. Let's go ahead and execute that, and that should give us the um, to run. Let's see. Yeah, so for this one, in this case, for the first sheet at least, I got the customer ID, the PO date, name, and everything is extracted like how I wanted it. However, there is a problem. I guess the first one is that we got the material details. So these are the details, and we got the material details. And if you see, the first line here is ideal logic max 24 kilowatt. So I got the first line, but that's not what we want, right? We want that first line, but we also want the rest of the stuff here as well. And the dot extract method, it only returns a text or a single line or a single entity, and um, not like lists or dictionaries or any other complex data types. So how can we overcome that? Let's go
Sandeep,
here.
there's another
Yeah,
question if that's okay.
yeah,
With
go ahead.
AI usually being GPU heavy in practice, does executing the AI function in a notebook count with a factor of 1x against the capacity, or is executing AI functions more costly?
So that's the beauty of it, right? This is provided to you as a service, meaning the LLM models, those are hosted on GPUs for inferencing. When you're using an API, so you're not using the GPUs because that is in the data center where the LLM is hosted. When you submit a command here, or when you ask something to the LLM, it is just going to send that request to the data center, and data center has the GPUs, and it will do the inferencing on it and send you the result back. So you're not using any GPUs on the fabric side of things. It's all done for you on the back end in Azure resources. As to the question of whether it is compute heavy, that will depend on what you're trying to do, and that will depend on the type of model you're using. So let's say, for example, if you go to the model catalog that is available in Fabric, there are different types of models. So there is GPT-4o, GPT-4o mini, GPT 4.1. All of those models, they have their own inferencing speed. Some generate tokens, or some generate the responses much faster than the other, and the trade-off is the accuracy. So it will depend on that. So it will depend on your query, it will depend on the settings you're using, the configurations you're using, and it also depend on the type of the model that you're using, and the size of the model itself that you're using as well. In case of AI function, by default, it uses GPT 3.5. Microsoft will update that. They'll add GPT 4.0, 4.0 mini, etc. The latest models, hopefully soon. If you have a need for, let's say, the latest model, and the GPT 3.5 or 4, 4.0 mini, those don't cut it, and you need to use something that is custom. Perhaps maybe you have a team of ML engineers or AI engineers who developed something. You can still use AI functions with it. So you can deploy that model, the fine-tuned model or your own custom model, in AI Foundry in Azure, And then you can pass the endpoint to AI functions and tell AI functions that, hey, when I'm asking something about for you, from you, use this custom model instead of the default model that's available in Fabric. So if you're worried about that, and if you think that for your use case it's taking much longer, then it's always a good idea to create a more slimmer, fine-tuned version of the model, and then create that endpoint in AI Foundry. Okay, so we did that. Now, what I want to do is extract the details, the material details, right? And to do that, we'll have to write some prompt. Um, and we can write the prompt in in a natural language. So and can tell the LLM that in plain English that, hey, I'm going to give you some data, and I need you to look at it. This is a purchase order detailed data, and I need you to give me type detail, material code, material description, quantity, unit of measure, and all of these details. And that may work in many cases. However, it is up for interpretation by the LLM as to what it is and what the data types are, and things like that. So one technique that's often used in structured data extraction and structured data generation is defining the schema and telling the LLM exactly what you want and the response to be back in. So in this case, I give it a prompt that, hey, this is purchase order, right? So extract purchase order details as a valid JSON, um, because we want that response back from the LLM in a very structured fashion. And this is originally from Excel, so it understands that there is a little bit of structure to it, and how to deal with that. And I want it to return only the JSON without any explanation, without thinking on its own, without filling in the details that are missing, etc. And then I also define what should the response schema be. That the PO date is a date, return it as a string, but in a format that is a DDMM YYY. Or the delivery type, there are three types of delivery types: so delivery, pickup, and shipping. And it can only be these three things. If it is anything other than that, just it should be null, and don't return anything else other than that. I also define here unit of measure. If it is not found, which is the case here, then it should return as null. Otherwise, it may return as 0, and we don't want that, right? So do that, and let's go ahead and this prompt. And then instead of the thing that I'm going to quick thing that I'll point out here is, instead of using dot extract or dot summarize or any of that thing, we are going to use dot generate response. And this is, I'll say, the most flexible of all the methods, that you can pretty much define the prompt, and then extract anything or get anything out of the LLM. So if you have function that is not available in here, then you can use generate response. So let's say, as an example, if I were to create something for this material description, right? I want to identify if this is maybe something that is related to electronics, um, or if it is related to hardware. And then if it is, then give me some common description about it, like what is this thing, right? There is no AI function for that, but you can use dot generate response method to do anything you want. So in this case, what I did was I passed it the prompt that I want, that how I want the response to be back. And I'm also going to do something that I will maybe show you before I run this command here, okay? So we got the df, right? So, but if I go to df.ai.stats, I think that's what it is. But ai.stats, Okay, not. Okay, well, we'll come back to it. I have an example for that. So for jumping there. Okay, so in this case, what I am doing is exactly what we did earlier, where I'm passing each of the sheets that I have to AI functions and then asking it to use this prompt and generate the responses based on that. I'm also giving it the max concurrency, like I had suggested earlier, and I get the number of tokens, and we'll talk about that in a minute. Right? What does that mean? So now I'm just looping over all the sheets, passing that to AI functions, and this shouldn't take very long. And now if we look at it, what we get is, let's just focus on this. So this is the markdown. So this is the data is what the AI functions return, the JSON file. Then this is what we pass to the AI functions, which is the markdown that I talked about. And let's talk about input tokens and output tokens, because this is very critical for you to understand. The way you will be charged in Fabric is based on the number of tokens that you use. And you can think about tokens as essentially um, all the text is converted into some numeric numbers called tokens. And the larger the text, the more the number of the tokens you have. And that goes for the text that you give to the AI function, which is input tokens, and that include prompt as well, and any system prompt, and the response that you get from here, which is the output token. And you'll be charged, and I have a calculator that you can go to my website to take a look at, where you can adjust that, and it will tell you exactly how much it costs you to do that. And now if I go to order DF here, you will see that now everything is in order, right? Now I've isolated my purchase order and then material details exactly like how I want it. But it doesn't stop here, right? What I'm going to do is uh, I'm going to run everything from below here, just in because we are running short of time, this cell and below, so that I can just walk you through this real quick. You can use the AI.stats to, so AI functions also has this AI.stats, where it gives you the same details, that what are the prompts that are input here. And then there was a question about operationalizing this, right? And this is where it is important that um, you evaluate it. And the way you evaluate it is, if I had this project, what I would do is create what the ground truth looks like, meaning what it should be, and then I will compare those results again what the AI function gave me. So in this case, you can refer to the details for block for the details. But in this case, what I did was I cleaned up the data. So I cleaned the data where I'm converting it into the right format and everything, and removing the things that I don't want. And this is the final order DF and the materials DF. And then I'm going to just compare that with the ground truth. Ground truth meaning what it should be, the actual value. And when I compare that, I get that the accuracy score is 1. That overall there are 324 sales. And out of those 324 cells, I also identify what are the differences. Maybe AI functions added something that is not supposed to, which would go in the addition, or something that was not present, then that would be in the deletion. In this case, we get a 100% score, and that may not always happen. But you, as the developer, it is incumbent upon you to go through that process and identify the if AI functions is working as it is supposed to work. And once you have done that, you will convert this into some sort of a function, or create a wheel out of it, and then put it in production, where you can use it on your incoming data. Um, there is again AI LLM in general being very stochastic, very statistical. There is never a guarantee that it will always generate the same responses. So you will have to create that loop as well to ensure that when you get the new data, you create new ground truth and then compare and make sure there is no drift, that it is not giving you the responses that it's not supposed to. An example would be that I created this for out of these four, but if I have a fifth sheet that is something like this, that is completely different from the four sheets that I created. Will it work on this? I don't know. There is no guarantee. But that's where this evaluation loop harness comes in handy, where you can go through the process, identify if something is different, and then alert your users. Or if you're working on some data that is very sensitive, or data that is, let's say, business critical, then perhaps AI functions is not good for you. Or in general, AI LLMs are not good for you. You need something that is more robust and something that is more deterministic. And AI is not the not the right tool in your case. So it is not magic. It will be upon you to make that determination and come to a conclusion whether it is a good use case for you or not a good case for you. We are running short of time, so if there are any other questions, let me know. Happy to stay here
Yeah,
or connect with me on LinkedIn.
perfect. Just another question there is now, what about the amount of data for a accurate result, a LLM?
The amount of data. So the amount of data, so there are two limits currently in AI functions. One is the how much data that you can pass to the LLMs, which is defined by the context window of the LLM that's used. In this case, it is GPT 3.5, which has a context limit of window of 16,000 tokens. So roughly, let's say in our case, maybe about 4 times the size of the data that I did here. This will improve in the future, but there are ways to get around that. And the second is the rate limit by Microsoft. Like you can pass 10,000 tokens per minute, which is large number. But if you're talking about hundreds of millions of rows, that's not going to work. You'll need some way to work on that.
Perfect. And next question there is, how do you handle data privacy and compliance? Example,
Yeah.
GDPR, when using Gen AI on sensitive, unstructured data.
Yeah, that's a good question, and there is no um good answer for that, because each LLM provider, each AI services, they have their own policies. Um, the nice thing here is that because you are within the Fabric ecosystem, those compliance requirements are applicable to all the workloads and all the features that you use within Fabric. So if your data is already in Fabric, it goes through the same rigorous process of data compliance and GDPR requirements. There is a button, I think, in tenant settings where that this data may be processed outside. So take a look at what exactly it is, and how it complies with maybe European policies and the requirements. Your data, because it is service managed by Microsoft, your data will not be used for training purposes. So that is private. It will not be shared with others. It will not be shared. It will not be used by Microsoft or OpenAI for further training. So there are those privacy guarantees. But always, read the fine print and come make your own determination.
Perfect. Yeah, someone just said super talk, Sandeep. Thank you for sharing your expertise. Really appreciate it. Another person said they're a fan, so.
Thank you.
Yeah, so that's all the questions. So on behalf of the ESPC community, we'd like to extend a big thank you to you again, Sandeep, for taking time out today to cover this webinar. Really appreciate it.
Thank you very much. Really appreciate the opportunity here.
So that's the end of today's webinar. You can find this webinar and more at sharepointeurope.com/research center. Thanks again for all of you for joining us today, and I hope you join us again soon. Take care.
Bye-bye.